We are back again with another final project for our PCS 7 tutorial. It's a very simple or simplified desalination plant, and the plant is in the steady state. It's in the optimum or optimal operating point, and we have this reset button. It's possible for us to reset the whole process and start it again, but now we are in the normal operation, and in this case I want to function test some abnormal cases in this plant. I want to increase the steam, the high alarm, the trip level for steam is around 11 bar. I want to increase that, and you can see after passing this limit, if we violate this limit, the plant will be shut down. It's a very simplified version. I will function test this I will function test over pressure. I will increase the set value to 15, and you can see that we have the increase when the steam pressure is increased based on the algorithm. Some other parameters in the plan is changing, but you can see we experience the high pressure trip due to steam high pressure, and the first trip out is also reported here. So let me press acknowledge and start the whole process again, and you can see that how the program is developed. The main part of the program, the backbone of the program, is controlled by this SFC block, and the control is done in CFC. We use the PCS7 library blocks in the PCS7 libraries, and we try to do some develop some program to make us able to be check the dynamic behavior of the plant. So when we start the process, you can see that the first step is to open the seawater after passing the this is the time measured time after 100 seconds. The steam will be opened, and we will build up some level here. This is the first level transmitter, or the measure level for the first part of the plant, and this is the desalinated water. Accumulation of desalinated water is here, and we will export the product by this pump. We have a measurement here for conductivity measurement and the rest. Steady state of the plant is somehow around 400 seconds after startup of the system. Everything is considered to be in the ideal situation. Everything is considered to be ideal, and I will cut the audio in order to see the process, and after reaching to the steady state, I will change some other when we are in the operating mode. I will change the theme again. I decrease the theme, and let us see what will be a result. Now the plant reached to the steady state somehow. We need to reach to the set value in the brine section, and we need to reach to the set value in the product. This part of the plant is the quenching process. We need to cool down the brine outlet and cool it down in order to protect the environment, because the brine outflow, the pumped this residue will be pumped again into the brine outflow, and we need to maintain temperature 30 centigrade, and this this valve is operating in the reverse mode in order to maintain the temperature. After reaching to the steady state, ideally the plant will work on all these set values, and you can see that this valve is transferring the product to the storage in case of having suitable value of conductivity. When we are in the safe region, when we are less than 3.7, it's safe to send the product into the storage. We need to consider this hysteresis value of 1 in order to avoid frequent changing in these valves. So the low limit is 3.7 and the high limit is 7. So I will cool down the entire plant. Consider that we are in the steady state. I want to cool down the plant and see what will happen. I decrease the amount of steam into the plant. You can see that the export valve is open, and when these valves are changing, we will receive the message here. Let me decrease it again, 7.5. The low limit is 1 bar, but the steam cut has negative effect on the product generation. The product generation will be decreased dramatically, and it has the bad effect on the conductivity. The conductivity will be increased, and these valves will be changed, and the product will be transferred to the outfall. The product will be rejected when the conductivity is not suitable for us. I will decrease more for you can see that this level, the product level, is decreasing, and the valve is not possible. The valve cannot maintain. The valve cannot maintain, and after some time, when this valve is closed for 10 seconds, due to the pump 1 protection, will shut down the whole plant, because when this valve is closed, we need to shut down the regarding pump. There is the same protection for pump 2. We have another protection for pump 1, and you can see that the first trip signal, the red alarm message here, is indication of pump 1 protection shutdown. So we need to press acknowledge, and we need to start again. The program is developed mostly in CFC. These are the program sections, and most of them are charts. We have SFC for a startup sequence, and some SCL sources for management and calculation. I will provide more details in the next videos. Let me reset. I will provide more details in the future videos, and the PCS7 tutorial will be available very soon on HD Hosseini website. Thank you for watching.